All right, hello everyone. Today we are getting into chapter 12, which is all about 3D shapes, which is also called solids in geometry. So all of these right here on the screen are considered solids, but today we're mainly going to be looking at polyhedron, or polyhedra in plural, which is a solid that has all polygon faces. So that means like the sides of the 3D figure, that's what a face is, are all regular, not regular polygons, but polygons. So here on the left-hand side, we have all of our types of polyhedra. We have a bunch of different other ones that aren't like these ones listed here. These are just a set of examples. But if you look off to the right, we have these other two figures. These are not polyhedra because the main thing is that they do not have polygon faces. A circle is not a polygon. So this, which is a cone, isn't a polyhedron, and we have here, which is a cylinder, isn't a polyhedron. But we have the ones on the left are. So for example, this one right here is a regular, or it's not a regular, it's a rectangular prism. And we'll be learning the different types of solids. We have this one is, this is a pentagonal pyramid. And we have this is a pentagonal prism. So we have a bunch of different types of solids, but as you can see here, like for example, we have a rectangular prism and then we have a pentagonal prism. We'll learn more about why those have those names when we learn more about prisms. But the main things that we need to note today is that on a polyhedron, we have a few different vocabulary words. We have a base, an edge, and a vertex, which I do have listed up here, very small, but we're going to look at what each one of these means. So first we have a base. So a base is just, it's the side that is it changes depending on the shape, but it is one of the faces. So again, it does change based on the shape. But faces are those 2D shapes. So things like squares, rectangles, circles are what we consider the faces of a 3D shape. So any shape that you can think of could be a face on a solid. Next we have an edge. So an edge is like if you imagine, for example, like a cube, if we were to draw one quickly, an edge is the side where two faces meet. So it would be like the side of each 2D shape would be considered an edge. So all of these are edges, these little segments. And then lastly, we have a vertex, which we've seen the word vertex before in geometry, but a vertex on a 3D shape is where those edges meet each other. So like all of these like points in quotation marks are vertices. All right, so faces, edges, and vertices come into play when we look at what we call Euler's theorem. So when it is Euler, okay, it's not gonna Okay, and that is pronounced correctly. It's Euler. It's not Euler. And here we have this formula. So we take the number of faces we have and add it to the number of vertices, and that's going to be equal to the number of edges plus 2. So we have that this can be used to help us find the number of faces given the number of vertices and edges, or find the number of edges given the faces and the vertices, or we can use it to help us verify whether something is a polygon or not, because not a polygon, a polyhedron or not, because it has to follow this theorem in order to be a polyhedron. So here we're going to take this piece of cheese and we're going to use Euler's theorem on it. So if you imagine like a block of cheese, it's a rectangular prism. And we're not talking about like a wheel of cheese, we're talking about like a block of cheese you would buy at the grocery store. And so if we take a look at this block of cheese, we want to list the number of faces it has, we want to list the number of vertices it has, and we want to list the number of edges it has. So for the most part here with these polyhedra, we can just count the number of things we have. So for example, if I want to count the number of vertices, I can do that. So I can be like 1, 2, 3, 4, 5, 6, 7, but then you have to remember that part of this picture is blacked, so we do have an 8th vertice on there. So we have 8 vertices in our block of cheese polyhedron. Next, we can count our edges. So we can be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges on our block of cheese. And if you want, you can get a block of cheese from your fridge and you can test this out because it's kind of a little hard to see in a 2D slide like this. And then lastly, we have our faces. So with our faces, we can count them. So we have the one at the back, the other one at the back, the one at the top, so that's 3, bottom is 4, front is 5, side is 6. So we have 6 faces. Now that I've drawn all over this, it doesn't look like a block of cheese. But we have 6 faces, 8 vertices, and 12 edges. So we're going to use Euler's theorem to just verify that this is a polyhedron. So we have 6 faces, we have 8 vertices, and that should equal to the number of edges plus 2, which it does, because 14 is equal to 14, so that works. All right, so we're going to take a look at some other polyhedron. We're going to be using Euler's formula with them, counting the number of faces, vertices, and edges. So we have this object off to the right, so this should be somewhat familiar to you. It's a pyramid. So we have, is the object to the right a polyhedron? And we want to explain. So, well, yes, this one is a polyhedron because it has a square base at the bottom, and it has a bunch of triangular faces on it. So we have all of our faces, including our base, and our other faces are polygons as a square pyramid. So that means that it is considered a polyhedron. And that just says pyramid on it. All right, so now we want to list the number of faces, vertices, and edges. We're not using Euler's formula here, we're just listing those numbers. So we have our faces, vertices, and edges, which we can count. So for example, vertices, we have the 4 at the base, and then we have the 1 at the top. So that is 5 vertices. For our number of faces, we have the base at the bottom, and then we have each triangular face going up to the point, so that's another 4. So we have 5 faces. And edges, we have the 4 coming off of the top, and then we have the 4 along the base on the bottom. So we have that is 8 here. All right, and this would work in Euler's formula, even though it doesn't ask us to do it. Let's just do it anyway. So we have 5 plus 5 for faces and vertices, and that's going to be equal to the number of edges plus 2, so that works out using Euler's formula. All right, let's take a look at another image. So here we have a baseball. So we have, is this object at the right a polyhedra? And we want to explain why. So if we take a look at a baseball is perfectly round. But again, our definition of a polyhedra is that we have polygon faces. So a sphere is just one big face. So with one face that's not a polygon, that means that this can't be a polyhedra. Or polyhedron, I forgot to change that one. Whoopsie. So a sphere is also added to the category of not a polyhedron. So in terms of the not category here, we have anything basically involving a circle is not going to be a polyhedron. Simple as that. All right, let's take a look at another problem. So here we have a standard 6-sided die, and we want to know if this object is a polyhedra, and we want to be able to explain it. So if you have a die lying around from like a board game or something, you can go get one, you can examine it, tell me if it's a polyhedra or not. I do want you to pause the video. You don't have to find a dice, but I do want you to think about it. As well as, if it is, list its faces, vertices, and edges and see if it works in Euler's theorem. So again, pause the video, try it out, then you can restart when you're done. All right, so we're going to take a look at this, and this is in fact a polyhedron. So yes, and we can describe this as a square prism, but basically all of its faces are squares on this die. All right, now we want to list the number of faces, vertices, and edges. So number of faces is the number of polygon sides it has, and with a dice it's going to be 6 because each side has its own number on it, so we don't even have to count that one. Vertices, we have 8. That's very similar to our block of cheese, even though it's a slightly different shape. It's just, it has the same number of vertices. And then our edges for this one is also 12. So when we're talking about a square prism and a rectangular prism, they're going to have the same specs of faces, vertices, and edges, even though they look slightly different. But now we're going to test it out, which we did with our block of cheese earlier. So it's going to yield us the exact same result of 14 is equal to 14. All right, and then I have one more little tidbit before you guys go on to your homework. It's just a type of vocab thing. So when we have what we call regular polyhedra, that means that all the faces are regular polygons. So we've went over the term regular before in geometry, but if you don't remember, Regular means that it has all the same side lengths and all the same angles. So when we're talking about a regular polyhedra, that means that all of those faces have all congruent sides and all congruent angles. So there are lots of different types of regular polyhedra. One example is like a soccer ball. A soccer ball is a regular polyhedra, even though I believe it's made up of, octagons and hexagons. Those are, that would be considered a regular polyhedra because all of the faces, all of the faces of the soccer ball are regular polygons, even though the ball itself is a sphere. So it's not, the sphere part isn't, but like the pattern on it is. All right, so if you have any questions, make sure to send me an email. We'll also be going over this on Zoom later this week, the second half of the week. So please make sure that you watch this video before then and try your homework before then. But if you have any questions, send me an email.